Good morning, everyone. In last class, we started with a linear search algorithm. So today we will start the class with a revision of linear search. Then I will start binary search. So firstly, what is a algorithm? A algorithm is a step-by-step description of the solution to any problem. So if we have a problem, then if we give the step to solve the problem in using simple understandable language, but not using any technical term, then this is called algorithm. Written in such a way, very simple and concise manner it is written, so that it can be understood by uh, everyone. That is, it can be understood by normal people also. First algorithm that you are going to see here is the linear search algorithm. So it is a very common problem to search a item out of a collection of n number of different items. So it is a very common problem in our day-to-day life. We encounter a situation where we have to search our belonging or a particular item out of a collection of n number of item. This if this technique, if the now there are now if we have to write a algorithm for this problem, then one algorithm of this solution is called linear search. So searching, as we know, searching is the objective or the process to find something. Search, we search something. That means our objective is that uh, we want our item. So actually, before doing the search, we have a picture in our mind that what it looks like. For example, um, suppose you have mm, suppose you have a good pen and you have kept your pen in your bag, and your bag contains suppose 4 5 different pens, then the one you are searching, you have already in your mind some information about the pen. Maybe the color of the pen, uh, maybe the name of the pen, and if the pen is very different, then the picture of the pen. If and when and so so like that. So when you are searching something in your mind, you have some information about your pen. Then about your exam. Suppose you have your exam, and in your exam admit card there is your seat plan, for example. Then when you are going for exam, you search your seat position in your in the exam classroom. Then your roll number you have in your mind, and when you search your seating plan, then you search your roll number. And if you forget your roll number, then what you do? are you able to search the seat plan? In your first semester or in your second semester, it happens sometime that you are using your admit card for the first time. Then you will definitely not remember your roll number. If it is a very long roll number, then definitely you will not remember it. Then what you do, you search for the first 3 or 4 letter, and then if you forget it, then you are not able to search. It is now it is not that the seat plan is written wrongly. Sometime it may happen, but most of the time you have a tendency to forget the roll number. So what you do, you recollect your roll number by looking back in the admit card. So that means some information in you have to remember before doing the search. Before you do the search, you have to remember some information. So that particular information is called as the target. So target means that we have to achieve. You must have a target. For your exam, you have a target to get 90%, or and for your college, you have a target to reach before 9 a.m., like that. And so you have target that this much target you have to achieve. So when you have a target, that means something already you have a set of mind. In your mind you have a set of confirmed, you have a confirmed number that this number you have to achieve. So the target can be a roll number, the target can be a name of a book, the target can be the color of your pen, target can be your friend's mobile number. So target means that one you are to achieve. Now this particular target, one by one you compare with the information that you have in your hand. uh, Now this WhatsApp group information that you have, WhatsApp number, you have a in your friends, you have a lot of friends and all numbers you definitely don't remember. Then what you do, you search from the top to the end, one by one. Suppose you want your friend's mobile number, and that particular mobile number you don't remember. Then what you do, you open your WhatsApp. You When you open your WhatsApp group, when you are in a WhatsApp group, when you open the WhatsApp group information, then all your friends phone number is there in the WhatsApp. Suppose you know the name of your friend, but you forget the phone number, or you don't know the phone number. Then what you do, you go from top to the end, and you search one by one that where your friend's name appear. So in WhatsApp there is a phone number, and in the right hand side of the phone number, most of the time some people give symbol, but most of the time people give the name, means they try to give the name. So when you register for WhatsApp, and sometimes people don't give the name, they give some symbol, but most of the time people give the name. So if you remember the name, then by the corresponding phone number you can find your friend's phone number. So what your target is, your target is your name of your friend, not the phone number, because phone number you don't remember. So your friend's name you remember, and now you search your friend's name in your WhatsApp group information. So you search your friend's name, and when you get your friend's name, definitely in the right hand side you will get the photo also. So and you will get the phone number also. And if you don't remember the name, if you don't remember the phone number, then you search the photo in your group information, that let me search the photo. May happen that I don't remember the name of the person, I also don't know the number, so so you may search the photo. So when you search the photo, from first to last you search. So when you search from first to last, that kind of a searching is called linear searching, and the target is the one that you have already fixed in your mind. It may be the face of your friend. So when you search your friend by the photo in the WhatsApp group, then in your back of your mind there is a photo of your friend, how he looks like or how she looks like. So you remember the face, or if you or if not the face, then some description. Maybe he or she is having some bike, or a photo of a mountain or something like that. So like that you remember, then you search. So you have a target in your mind, and so that target is compared linearly. Linear means in a line, from first to last in a line. So you are not going to do jumping, means you first search in the first phone number, then go to the last phone number, then come and search in the middle. Our normal human tendency, that if when you want to search something in a WhatsApp group information, then we do the searching from first to last. From we first see the first phone number, if that photo match, then, and if the name also match, then yes, that is the particular target, that my friend, and I get the phone number. If the first person is not my target that you are looking, then go to the second. You are not going to the third. Okay, so very closely you look in the second photo, then you look into the second person name, then you look into the third photo, then the third person name, then 4 5 6 up like that, up to the last, so you are not doing jumping. So this kind of searching is called linear search process. This kind of searching is called linear search process. So why this searching is required? Why searching is required? So when you are using Facebook, and when you want to in WhatsApp group, in WhatsApp group information, in WhatsApp group, what you do, you search yourself. But suppose in Facebook you have to find a person, then you type some name of that person, and then how the Facebook search. Now Facebook also have to write this kind of a program. Now in the Facebook, the engineer, they write this linear search program. They write the linear search program, and what is the target given by the person whose account you are, means your account. So you log in to your account, and you type name of, suppose you type the name of, suppose Shahrukh Khan, like that. So Shahrukh Khan is the target, and in the Facebook now will search from a set of items. Facebook will search from a set of items, and so A to Z, from first to last, everything it will search. From first to last, everything it will search, and whenever this particular person is found, it will give reply to you. It will give you the reply that this is the page that is been found. So that is why our normal day-to-day activity, day-to-day whatever we are doing, in our back of the mind, we do not we forget how we are doing the searching. So when we search some phone number or some person information manually, when you are doing manually, for now, another example, when you go to library and you search a name of a book, so you search from the first to last, but in our back of the mind, we are not thinking so much about how our brain is functioning the search. What we are doing, we go to the library, we register our name, we go to our department book shelf, then you search for your book. Now if you observe, you start to search from the book, your book from the first bookshelf. Then the first bookshelf you search every book. You are not doing the jumping. If you were doing the jumping, then definitely you will miss the book, you will not find your book. So be very carefully, those who visit the library regularly, or even if you are visiting the library for the first time, or you go to the library regularly, still you have to, you have a human tendency, it is the natural human tendency that we search from first to last, because we don't want to miss even if it is in the middle. So, but if you jump, if you go to the first book, first bookshelf, then just 10 or 15 books you search, but remaining you not look into. Then you go to the second bookshelf, only 10-15 book you search. Then what will happen? There is very less chance that that you can find that particular book. So in our back of the mind, we are searching every day-to-day life. Every time we search something, every time, maybe it may be your um, something that if you are in the kitchen and if you are looking for the box of, now everyone is in your home, most of the time people like have now spend time in cooking their own, because restaurants and everything is closed. So when you like to eat something good, what you do, you tell, or you yourself you prepare it, that restaurant kind of a food. So when you prepare this, most of the time what you do, if you are going to the kitchen after a very long time, then suppose you want to find the box of the salt, then what you do, you search from the left to right, that where is it. Okay. And and in our kitchen item, is in the box, in the box outside, paper will be put, and there it will be written salt, and another box paper, in on the piece of a paper it will be written sugar, then haldi, like that. And then you search from left to right, then you find it. But if you just go randomly, you will not find very less chance to find. So you see, in our day to day life we use linear search, every time we use the linear search. So this searching technique is used by the computer also, and that is why it is a important learning algorithm, linear search. Then binary search. So this particular algorithm is important for you. You have to remember this 3 lines. So in overall what this algorithm is saying is, traverse the array using a for loop. Now here some technical term is there. Traverse means to move. Traverse means to travel. Traverse word come from travel. So travel means going from one place to another place. So traverse the array using a for loop. Now traverse means to travel. Now array means array means a set of item. Series, you understand series? Series of event. Series of event. Series of event means one after the another. So array is a series of collection of item. So travel the series of item using a for loop. Now what is a for loop? For loop is a mechanism that the computer used to travel from first to last. It is a mechanism, so it computer used to travel from first to last. So you have to remember this line, traverse the array using a for loop. Traverse word come from the travel, and array means a series of item. It may be any item. So array means it's a series of item. And for loop, you understand loop is means it's like a loop of rope. When you make a loop, then it becomes circle. Loop, when you tie your shoelace, you make a loop. When you put rubber band, you make a loop. Loop is like your rubber band. If you see the rubber band, it is like a circle, so that is called a loop. Now the meaning of the circle is that what you where you search, where you start, you come back to the that position. Okay, now very interestingly, how you know how our means how we understand that the say item that we are searching is finished. Very easy. uh, when you when you search for now let us take another example. Suppose you are using the a calendar, and suppose you are using the calendar in and if you use the lunar calendar means our now every I hope every one of you are from the northeast. So in the northeast, or mostly in Assam, there is a there the month starts from April, in the mid of the April, not from the 1st of January. And I hope in the rest of the remaining states also there is some pattern like this, where the month where the new year, that is your means your festive new year, not is not the 1st of January, but April 14. And that date is called this starting of the new year. And sometime what happens, it not always the fixed date that it will be 14. It may be sometime 13, it may be sometime 15, maybe sometime 16, depend upon the means the moon position. So when you so how to understand that when is a month started and when is a month complete? A month start and month complete, you look into the calendar, and suppose you look into the calendar from, suppose you start from the 14, then you 14, then you when you go uh, from 14 to 15, 16, 17, 18, 19, 20, like that you go 31, 1, 2, 3, 4. When you again come back to 14, that means you have completed 1 month. Okay, similarly, how in the calendar, how we understand that 1 month has been completed? Sometime the month is ending in 30, sometime month is ending in 31. How to know that a month have completed? You start from 1. So 1, 2, 3, 4, 5, 6, 7, 8, 19, 30. After 31, if it is a 31, after 30, if it is a 31, then okay. After 30, if it is a 1, that means you have completed 1 month. Yes or no? When you start from 1, you start 1, 2, 3, 4, 5, 6, then you again come back to 1. Means you, when you start your position and you come back to the same position, this is called a loop. One loop. It is called one loop. Loop means with the starting position and ending position, if it the same, that means our item that we are looking for is the complete. There is no more any more left. There is, if after 30, if the 1 is coming, that means our, suppose you have a exam date, you have, that particular date will be inside from 1 to 1, inside 1 to 1. 1 to 1 means 1, 2, 3, 4, 5 up to next 1. So 1 to 1, 1 to 30 if you take, then you are not sure that whether it is a 31 should be included or not. And 1 to 31 if you take, then you are not sure whether this month have 31 or not. Then what is the easy way to find? From 1 to 1 of this month to up to the next one. Sometime February have 28 days, so now you cannot take 30 also. And so what is the easy way to tell that is, you start from 1, you go 1 2 3 4 5 6 like that, and again when the next time 1 comes, that means you stop there, no need to count anymore, because 1 month is complete. So 1 to 1, so this is called a loop. So you will, so start, so this is called, that is why uh, loop is mentioned here. Because in our day to day life we are doing this thing, but we are not thinking that how this searching is going on. Means, but in the computer system, every detail you have to mention. Okay, every detail you have to mention. That is why so many technical terms is used here. Traverse the array using a for loop. Step number 1. Step number 2, in every iteration, every iteration means every time you go from one item to the next item, you compare the target. You compare the target means the one you want to search. So the target you compare with your value. If there is a match, then you you return the index, current index. These are some of the technical things, but you have to just remember the overall what is going on. If the value do not match, move to the next array element. Now move to the next array element means move to the next element. You understand, element means a part of the series. Move to the next element of the series. Next element of the series means next item. Okay, next item. If no match is found, -1. So after doing a complete search from first to last, if your target is not having any matching with the list of item, so you have a target with you, then and you have a list of item with you, and you measure the target and the list of item, they should be same. If they are the same, then you tell that in what position that is been found the same, whether it is found in the position first, whether it's found in the position second, whether it's found in position third, fourth, middle, last, second last, third last. This is called index of the array, or the current position. And if value do not match, if it means if you start from the first, if the value match in the first, then you return. Return means you tell the person that searching, you tell that position 1 have the value matching. It's doing the matching. And if the value do not match, go to the next, and from first to last you complete everything. Still if no match is found, return -1. That is the step number 3. This is your linear search. Next, another algorithm is there. This is called binary search. Now this algorithm, binary search. First algorithm is the linear search. This one, binary search. So in binary search, what we have to do in binary search? Firstly, you have to arrange the your list of item in a increasing or decreasing order. In linear search, there is no fixed order. Means should not be any fixed order, increasing smaller to greater or greater to smaller. There is no fixed order. Linear search, in linear search. So in binary search, in the second method of algorithm, in the second way of doing the solution, in the second algorithm, binary search, the algorithm start, but before starting, the item, list of item have to be in a increasing or in a decreasing or in alphabetically alphabetically order A to Z or Z to A, or if it is a number, it should be increasing to decreasing or decreasing to, it means there should be some order. it cannot be a number randomly. In linear search, if we have a list of item 1 minus 1 5 0 9 5 4 100 12 14, that is okay. But if we are doing the binary search, we have to put the number in sequence: minus 1, then 1, then 0, then 2, then 3, then 7, then 14, then 18, then 100, then 200, then 225, so like that. And if it is a name of a person, then first or if it is a name of containing alphabet, then it should be first, suppose Akash, then it should be suppose uh, so like that, Akash, Akashdeep, and so like that, Bikas, then Rishikesh, then Trilok, so like that, in A B C, that kind of a order. That is the first rule of binary search. Then what you do, then you to do it successfully, first we select the middle number. When we have a list of item in A to Z alphabet, A to Z, it is arranged alphabetically A to Z, or it is arranged in number 1 to 100 or 1 to 1000. And when you have to search something, when you have to search something, then you start in the middle, and exactly in the middle. And if the target means that our picture that we have in our mind, or the number that we have in our mind, or the name of the person that we have in our mind, that we have to search, this is called the target. If the target is more than the middle, okay, middle, you understand, the middle of the list, and target is the one that we have to find. So if the target is more than the middle, then you search the means the second part of the list. And if the target is less than the middle, then you search the first part of the list, and no need to search anymore for the second part of the list. Okay, for example, there is a list of number and you want to search 65. Suppose you are to search that whether the 60, now firstly 65 may be there, 65 may not be there in a collection of item. So there is a list of number from between 1 to 100. Suppose some number, random number, suppose says to marks of a student, marks of your class have suppose 70 students, then all the 70 students out of 100, there is a set of marks, and all arranged in sequential manner. And you want to search that whether 65 is there, or whether someone has got 66 65 or not. 65 means exactly first division, or 60%, 60 marks, 60 means exactly first division, 59.5 means second division, 60.5 means first division. And what about the 60? So suppose you want to find, your class teacher wants to find that is there someone in the border means now you cannot tell 60 is more than 60, you cannot tell less than 60, but definitely it is means in the border 60. Now what to do about this student? So firstly you have to find whether a 60 someone have got 60 or not, and whether whether it is and the name of the student. So suppose now what is the best solution? Now out of if there is 70 student, then maybe it is very easy. But imagine if there is a list of the entire university student, all university 2500 student list is there, and the exam department have to find someone is in the borderline 60. What to do? Whether to give him second division, whether to give him first division. Suppose some kind of a doubt come, then to search 2000 3000 student one by one, it is means doing the linear search, it is going to take time. what is the best first solution? First solution is arrange the number in order. Arrange the number in order 1 to 100. Give all put every student in a order the marks. Now you have to search whether 65 is there or not. You have to search whether 65 is there. No, definitely no one will get 1 out of 100. Definitely no one will get 1, no one will get 2. Okay, so but you have to keep them also 1. So the so 1, because someone may get, okay, so if someone may get 1, someone may get 2, but not, but it is not that after 2 3 will be there, after 3 4 will be there. Yes or no? You cannot tell that this time at least one student will get 3, one student will get 4. No one can get 3 in the whole university. Out of 100 marks there cannot be, sometime it may happen, once some semester it may happen, no one get below 10. So what then what to do? So you arrange the number in order 1 to 100. Then you start in the middle, you look exactly in the middle. In the, if there is a 3000 student, you arrange the number in order, ascending order. Then you look into the middle, position number 1500, middle of 3000 is 1500. So you look into the 1500, what is the number in the 1500, and you are looking for the target 60. So if this 1500 position is less than 60, if the mark of the 1500 student, means if the mark of the student in the position 1500 is less than 65, that means that means you have to search now the now no need to again start from the first, no need to again start from the first. You can take a lunch break. After the lunch break you can come and start from the middle and go and look into the second half only, look into the second half only. Now suppose you have a big list of student to find, and when you search, when you are doing this kind of a problem, and it may happen that you don't want to take a break, because if you take a break then you will forget what was the last position you. But when you do binary search, you can just look into the middle, and you can tell that if the middle is less than or greater than 65, then you can tell that okay, the first half of the list I don't have to search, because since the list is in ascending order and I am want to search 60, and the position number 1500 is suppose 55, that means position number 1400 is also somewhere between 50 and 55, because they are all in ascending order. So when you come back from the lunch, you can if someone ask for, if some teacher asks that I have to find the list of students who get less than 40, because I have to give them the fail result, then what you can do, you can happily give the teacher, okay sir, you take the first half of the all the student marks, because I am only searching for those students who get only exactly in the border 60. Because you are doing binary search, you have found that in 1500 position the mark is 58, but your target is 60. So what you can do, the first half, the first 1500 you can give to the teacher, and he will now find how many students get less than 40, means the fail mark. But if you are doing linear search means all the 3000 student, you are not doing the binary search, means the list is not in ascending order, you are doing the linear search. Which list of which student get exactly in the border 60. Now you are doing some searching, you have finished 100, now you want to take a break. You cannot take a break. If the student, if some teacher asks you that sir, please give me at least the first 2-3 pages of marks so that I can find who has got less than 40. You can only give the paper to the teacher once you complete everything from first to last. You cannot stop in the middle, because you cannot guarantee that you may miss, because you are doing human, you are doing manually, 3000 student, you are doing the comparison to find which student get 60. So until and unless you complete, until and unless you do re-verification, at least verify 2-3 times, there is a chance some students. So you cannot give, blindly, you cannot give. If you are very careful, everything very nicely you have calculated, okay, then you can give to the teacher, okay sir, take the first two pages, you take, I have completed the 100 student out of 3000, then you can give. But our human mind is such that if you are doing a problem of so big nature, we are afraid that, okay sir, don't take it now, I have to complete and I have to verify whether my result is correct. But if you are doing binary search, all the number arranged in sequential, then you want to search 60, then you see that the first 300 400 student all are getting the marks 200 300 is 550 50, first 1000 student all are getting 40 50. If teacher comes, sir, can you give me the first 600 student list? Yes sir, please take it. All are getting less than 40, because because your number marks all arranged in sequential order, from starting from 1 2 3 4 5 6 up to 100 for 3000 students. So binary search, firstly you do it sequentially, then you see in the middle, that exactly in the middle position what is the number. Then if the middle position number is less, then you first half of the, then you throw the first half, you don't need the first half anymore, you can give it to different student, you can delete it, whatever you do, you not require it anymore. Okay, then you go to the second half. The second half means from 1500 up to 3000. In this 1500 to 3000, again you search in the middle, whether your 60 is there or not. If this time 60 is there in the first half, then the second half you no need to search anymore, you can delete it, or you can throw, or you can give it to someone else. You search only in the now in the in this small list. Then again you search in the middle, then you search whether this particular middle number is less than or greater than. If less than, you take the left side of the half, if greater than, you throw the left side, take the right side. So your list become very small and your time is saved. This searching method is called this searching pattern is called binary search. This searching algorithm is called binary search. Okay, this have advantages and very fast.